right? A chord of the circle. A chord of the circle is a line joining any 2 points. A chord of the circle is a line joining any 2 points on its circumference. Joining any 2 points on its circumference. So stop. A diameter is a chord. A diameter is a chord which passes through. A diameter is a chord which passes through the center of the circle. A diameter is a chord which passes through the center of the circle. Full stop. A chord which is not a diameter, a chord which is not a diameter divides the circumference into 2 arcs. A chord which is not a diameter divides the circumference into 2 arcs of different sizes. Comma, a major arc and a minor arc. A major arc and a minor arc. Then you draw this diagram. This is the diagram. Okay. This is a chord. This is major arc. This is minor arc. This is minor segment. This is major segment. Now, I'm not here to find the area of segment or find the length of chord, but to explain some of the theorems, because in this type of topic we have some theorems, and when you look at some textbooks you will see theorem 10, theorem 11, theorem 12 and so on and so forth. There is nothing like theorem 12, okay? They are there for reference purposes, because some students will just tell you, do you know theorem 12? Do you know theorem 13? There's nothing like that. In fact, theorem is what you have been doing right from, let's say, primary school. Because when you have sum of angles on the straight line, it's a theorem. Sum of angles on the straight line is 180, it's a theorem. Sum of angles in the triangle is 180, it's also a theorem. So, theorem 1, theorem 2, they are there for reference purposes. So there's nothing like theorem 18, theorem 20, and we have a lot of them. And in this topic, before you can solve any question, you must know the theorem. Not that you should go ahead and know how to prove, but you must know the application of the theorem. We have so many theorems, like exterior angle of a triangle equals what? Sum of its opposite interior angles. We also have some theorems on circle, like angle at center twice angle at circumference. Angle in a semicircle is what? Right angle. Angle in the same segment are equal, and so on and so forth. In fact, if you look at the past question, there's nothing like prove this theorem. In the past, they used to say that question, but they are no more setting it. So you don't need to bother yourself on how to prove some of this theorem, but you must know the application of each theorem. I hope that one is taken. Now let me quickly explain this. This is a circle. And when you have a circle must have what? Center. This is the center. According to that short note given to you, that a diameter is a chord. Yes. That chord is a line that is drawn from one point on the circumference to the other. Now this is a chord now. From here to here is a chord. Even if you draw a line that passes through this center, it's also a chord. But this diameter is a special chord. Are you with me now? And so this is a chord. This is what is called minor segment. This is minor segment, while this place is what? Major segment. We also have what is called major arc. From here to here is major arc, while this one is what? Minor arc. Are you with me now? So let's talk about the first theorem under this. Theorem. A straight line drawn from the center of a circle to bisect a chord which is not a diameter, is at right angles to the chord. Now look at this theorem. Now the summary of this theorem is that a line that is drawn from the center of a circle bisects the chord. It bisects the chord, that is, it divides the chord into two equal parts, and it is perpendicular to the chord. That is what the theorem is talking about. A line that is drawn from the center of a circle bisects the chord, and it is perpendicular to that chord. But you must know that if that chord happens to be a diameter, you cannot use the theorem here. Because if you have a circle like this, you know, the theorem states that a line that is drawn from the center bisect the chord, that is, this side is equal to this. Are you there? But if you now have a chord as diameter, there is no way you can use the theorem. That is why we have a straight line drawn from the center of the circle to bisect a chord which is not a diameter, is at right angle. Let me now explain the reason. This is called radius. This is radius. This is another radius. Okay, now I want to explain the reason why these two angles, this angle is equal to this angle, and it is 90 degrees. The reason. Now, this is radius, this is R, this is also R. Okay, we have been told that it bisects this chord, that is the line that is drawn from the center, bisects that chord. And if the line bisects that chord, it means it divides into two equal parts. Now, this side is equal to this side is equal to this, and this line here that is drawn from the center is common to the two triangles. That is what is called SSS, incongruent triangle. What I'm saying here is that if it is possible for one now to remove this triangle and place it on this one, we are going to have the same thing. Am I communicating? So if you now label these as, let's say, A, O, B, and call this one M. Now, I already know that this side bisects, this line bisects the chord. This side is equal to this. We can say AMO plus OMB, which is equal to what? 180 degrees. That is one theorem, angles on a straight line. Now, AMO is now equals to OMB, which is now equals to 180 degrees all over 2, and that is 90 degrees. So that is why a line that is drawn from the center bisects that chord, and it is perpendicular to it. But you know, there is another theorem which states that when you have a chord like this, look at this chord. This is a chord. You draw a line from this, it is perpendicular. You draw another one, it is perpendicular. You draw another one. But when you now have that chord, if that chord now becomes the tangent, it is still perpendicular to the line that is drawn from the center. Am I communicating? So what I'm saying here is that this line that is drawn is perpendicular to the what? Tangent. Is that taken? Now let us now try some questions on this theorem. The first one. A chord of a circle is 12 centimeter long. A chord of a circle is 12 centimeter long. Full stop. A chord of a circle is 12 centimeter long. Full stop. The radius of the circle is 10 centimeter. The radius of the circle is 10 centimeter. Full stop. Calculate the distance of the midpoint. Calculate the distance of the midpoint of the chord. Calculate the distance of the midpoint of the chord from the center of the circle. From the center of the circle. Now look at this question. Now, if you have a question like this, you must start by drawing the diagram. Diagram is very important here. To any question that involves Pythagoras rule, you must draw a diagram. Because I cannot be using hypotenuse square is equals to opposite square plus adjacent square without having a right angle triangle. So we have a circle. Let me draw that circle. This is the circle. We have center. Please, let somebody read the question for me. A chord, okay? I'm listening. A chord of a circle is 12 centimeter. Now listen. A chord is from here to here is 12 centimeter. Okay? Continue.
The radius of the circle.
The radius of the circle is what?
10 centimeter.
10 centimeter. As this one, as the radius here is 10 centimeter, this one too is 10 centimeter. Okay?
Calculate the distance of the midpoint of the chord from the center of the circle.
Midpoint of the chord from the center of the circle. This is the distance. This is the distance. And don't forget the theorem. We state that a line that is drawn from the center of the circle is perpendicular to the chord. We put 90 degrees here. And there's another theorem here too. That this line bisect this 12 and get what? 6, 6. So what we are now looking for in this question is this, x. So, you know, some students, they be using x squared plus this without having x in the diagram. It's wrong as well. So you need to indicate that x in the diagram. So in this, what we are going to use to solve this question is what? Pythagoras theorem or Pythagoras rule. But, you know, anytime you want to state that Pythagoras rule, it is wrong for one to say opposite square is equals to adjacent square plus hypotenuse square is equals to opposite square plus adjacent square. No, that's not how to state that Pythagoras rule. You need to, because I can only identify only the hypotenuse in that triangle. When you have a triangle like this, I can only identify the hypotenuse. This is the hypotenuse. Which one is opposite? I don't know. I don't know the opposite or adjacent. So that's why anytime you want to state that Pythagoras rule, you must state it as in a right angle triangle, the square on the longest side, which is the hypotenuse, equals sum of the squares on the remaining two other sides. I know that it is opposite and what? Adjacent. Are you with me now? Okay. So with this, it is this hypotenuse that will stand on its own. X squared plus 6 squared is equals to what? 10 squared. Then we have s squared plus 36 equals to 100. S squared is equals to 100 minus 36. S squared is equals to 64. S equals to square root of 64, and that is 8 centimeter. That is the distance of the midpoint of that chord from the center is 8 centimeter. I hope that one is clear. Now let us look at the second question. You know, it is very important to put units. Don't just write s equals to a without putting centimeter. If you don't put that centimeter, that is minus 1. Please make sure you always put that unit. Number two. Calculate the length of a chord of a circle. Calculate the length of a chord of a circle. Calculate the length of a chord of a circle of radius 26 centimeter. Calculate the length of a chord of a circle of radius 26 centimeter. 26 centimeter, 26. If the chord is 10 centimeter, if the chord is 10 centimeter from the center of the circle. If the chord is 10 centimeter from the center of the circle. Now look at this one too. Now let me first draw the diagram, circle. Now we have this. This is the circle. Now what do we have in the question? Do we have a chord? What's the length of that chord? That is what we are looking for, right?
Yes.
Okay. What else do we have in the question? We have radius. What is the radius? 26 centimeter. Okay. As this one is 26, there's another 26 here. Or there's no need to draw the second radius. Just leave it. But you must draw this line from the center, which is perpendicular to the chord. Okay. Do we have the length of that line? What? 10 centimeter. Now what are we now looking for? Length. Length of what? Of the chord. So I will call it YY. So that after getting Y, then I will now multiply by 2. Then how are we now going to get Y? Pythagoras rule also. Y square plus 10 square equals to 26 square. Because it is that hypotenuse that we always stand on its own. So Y square plus 10 square is equals to 26 square. So we have Y square plus 100 is equals to, what is 26 square? 676. Then we have Y square is equals to 676 minus 100. Y square is equals to 576. Y is equals to square root of 576. 24 centimeters. Please, do you know the reason why we always ignore the negative sign here? Because anytime, if it is objective question, and you have this, Y square is equals to 576. If it is objective question and you have option A to be 24, option B is minus 24, option C is plus or minus 24. Plus or minus 24 is the answer, because every quadratic equation must give you two answers. So we can ignore that negative sign because that one is not applicable to this question. When we are talking of length of something, there's no way you can get negative. Okay, so that's why we are going to use only positive answer, 24 centimeter. But that is not the final answer, because the question is to find the length of chord. Length of chord is, or is equals to 24 plus 24, and that is 48 centimeter. Is that taken? Now, I will still give you the last example on this one. Then I will give you classwork to do before we continue with another aspect of this topic. Are you ready? A chord XY of a circle, of radius 3.5 centimeter. A chord XY of a circle of radius 3.5 centimeter. Subtends an angle of 120 degree. Subtends an angle of 120 degree at the center. Full stop. Calculate the length of the chord XY. Calculate the length of the chord XY. Calculate the length of the chord XY. Now let me still draw the diagram of this one. This is the diagram. We have we have a chord, and the chord subtends an angle of what? What is the angle? 120 degree. 120 degree. Do we have radius in the question?
Yes.
What is that?
3.5
centimeter. You can put O here. As this one is 3.5 centimeter here too. So we are looking for this length of chord. You know, there is formula for that length of chord. I gave you that formula under longitude and latitude. And what is the formula? 2r sine theta over 2. You can use it. Length of chord equals to 2r sine theta over 2. But don't use this 2 to cut this 2. It's wrong. And don't change that small r to big R plus alpha. We are not dealing with longitude latitude here. Our radius here is 3.5. Although if you don't remember this formula, you can divide this and change this one to 60 and use trig ratio. Call this one maybe A, opposite. If this one is A, this is also A. So now I'm going to say opposite hypotenuse, sine. So I'm trying to derive the formula again. When you have opposite, you know that when you have this, theta, r, you divide. This one will give you theta over 2. Let's call this one A and call this one A. Opposite hypotenuse, that is sine. Sine theta over 2 is equals to opposite A hypotenuse r. Cross multiplication, r sine theta over 2 is equals to A. And how many A do we have? Times 2. Length of chord is now 2r sine theta over 2. That is length of that chord. So that's how to derive the formula. So with this, you can now do the substitution. 2 times r is 3.5 times sine 120 over 2. So it will now give us 3.57 times sine 60. Sine 60. And what is sine 60? 0.8660. Multiply. 6.06 centimeter. So if you use this formula of mine here, you are not multiplying that A by 2 again. No. Okay, maybe let me clean this. It is only when you are trying to when you are trying to use trig ratio, and you call this one AA, that you use opposite over hypotenuse. I've already used everything directly here. Is that taken? So don't multiply this one by 2. But if you solve it one by one by using opposite hypotenuse, after getting this place that I name as A, you must now multiply by 2. Is that taken? Now before we continue, let me give you what to do. I will give you one question on this aspect. Then I will allow you to solve it before going to the next one. Now take this as classwork. Classwork. A chord of length 24 centimeter is 13 centimeter from the center of the circle. Calculate the radius of the circle. Now try the question. You have just 5 minutes to do this. You have just 5 minutes to do this. You have just 5 minutes to do this. You are done? Well, I need a girl. Yeah, do you want to? Ashero. Yeah, I want to. Okay? Don't worry about the diagram. Okay? Okay. Why can't you clean that 24 if you have named it and stored it? I hope that one is clear. Okay, now. that the answer? Is that the answer? Please clap for her. Okay. So that is how to solve that question. Now I also have another question on this topic. Are you ready? Now write the question down. Two circles with centers. Two circles with centers X and Y. Two circles with centers X and Y intersect at A. Intersect at A and B. Intersect at A and B. Full stop. Intersect at A and B. Full stop. If the radii of the circles are 20 centimeter, if the radii of the circles are 20 centimeter and 15 centimeter, if the radii of the circles are 20 centimeter and 15 centimeter, and AB, capital letter AB, is equals to 24 centimeter. Capital letter AB equals to 24 centimeter. Come on. Find the distance between the centers. Find the distance between the centers. Find the distance between the centers. Now look at this question. There's not much in this one because if you really understand the first aspect of this topic, you won't have problem in this one. So what we just have here is that we have two circles that intersect. So you must also draw the diagram because if you don't draw the diagram, you'll not be able to solve the question. So we have two circles that intersect. The two circles intersect. This is the first one, and this is the second one. The two circles now intersect at A. Intersect at A and B. Now we also have that X and Y are the centers. I mean, X and Y are the centers. This is it. X and Y are the centers. Now, what is the, okay, AB is given as what? 24. AB. Now, what is AB to these two circles now? Chord. Okay. And you know that there is one theorem which states that a line that is drawn from the center is perpendicular to the chord. And I can still draw this one too. It's also perpendicular to the chord. Now, this is radius. And this is the second radius. Or you can even complete it and draw this. Okay. Now, I hope it is clear. Okay. Now, what is the first radius that we have here? 20. What about the second one? 15. Now, we have been given that AB as what? 24. Then this length is 12. Abi? This one is 12. And this one too is 12. Now, what are we trying to calculate in this question? We now want to find the distance between the two centers. Now, I can bring out the two triangles, the two triangles that we have in this one. Let me bring out this. This is X here. This is X. X is here. This one is 20. This is 24. Maybe we should call this one A. A. Then for okay, see, this is 12. This is 12. Then the second triangle is this. Now this is 12. This is 15. Let's name this one B. Now, if you are able to get length of that A and length of that B, to know the distance between the two centers is going to be what? Is it addition or subtraction? Addition. Now, from this, it is Pythagoras' rule that one we can now use here to get A. And which one is the longest side here? 20. So it means A squared plus 12 squared is equals to 20 squared. So we have A squared plus 144 is equals to 400. That is 20 squared. Then we have A squared equals to 400 minus 144. Then we have A squared is equals to what? 256. A equals to square root of 256. And that is what? 16 centimeter. Always put that unit. Then you now solve the second one. This is b. Which one is the longest side here? 2. 15. So it means b square plus 12 square is equals to 15 square. So we have b square plus 12 square is 144 is equals to 225. B square is equals to 225 minus 144. B square equals what? 81. And what is the square root of that 81? 9 centimeter. Now distance between the two centers is distance between the centers. The centers is equals to A plus B, and that is 16 plus 9, and that's 25 centimeter. Is that taken? So that is how to get that one. Is there any question? No. Parallel chords of length, 2 parallel chords. 2 parallel chords of length 10 centimeter and 14 centimeter. 2 parallel chords of length 10 centimeter two parallel chords of length 10 centimeter and 14 centimeter lie on opposite side of a circle. Lie on opposite side of a circle of radius 24 centimeter. Lie on opposite sides of a circle of radius 24 centimeter. Of radius 24 centimeter. Comma. Find the distance between the chords. Find the distance between the chords. Find the distance between the chords. Now, in this question, we have just one circle, but we have 2 chords, 2 parallel chords. You know, if 2 lines are parallel, it means that they are keeping the same distance, and there's no way the 2 lines will meet. Abi? So let me interpret this question too. We have a circle. We have a circle. So we have 2 parallel chords that lie on opposite side. There is one here and there is one here. If I change that question to 2 parallel chords lie on the same side. If the 2 chords lie on the same side, that's another thing. Because if you have them on the same side, one is here, the other one is here, and you cannot label it anyhow. Because, okay, what is the length of the first chord in the question? 10. Okay, the first one that is 10. Okay, let me draw a line from the center here. The one that is 10, 5 centimeter. Abi? What about the second one? 14, 7. But if the 2 of them lie on the same side, you cannot just interpret it anyhow. Because the one that is 10, will be here, 5. The one that is 14, 7. No, it will be wrong for one to now put 7 here and put 5 here. But if the 2 of them lie on opposite side, I can put 5 here, 7 or 7, 5. I hope that one is taken. Okay, so with this, do we have radius in the question? What is the radius? 24 centimeter. And we are going to have the same radius. We are going to have the same because we have just one circle. Unlike the first one, where we have 2 intersecting circles. That's why we have 2 different words, radii there. Okay, so with this, we are trying to find the 24 centimeter. Unlike the first one, where we are now looking for distance between the centers. Here we are looking for distance between the chords. So I can still use x to represent this distance, while this one is y. It is still Pythagoras rule that one we use here to get the values of x. So look at this. We have, this is 5 centimeter, this is 24 centimeter, while this one is x. The second diagram here is this. This is the way we have it. We have y here, 7, while this one is 24 centimeter. Now with this, that is one, anytime you want to state that Pythagoras, we must first identify the hypotenuse. where this right angle is facing is hypotenuse. So s squared plus 5 squared is equals to 24 squared. It is that hypotenuse that we always stand on its own. So s squared plus 25, that is 5 squared, equals to what is 24 squared? 576. Then s squared is equals to 576 minus 25. What do we have? 551. Square root of that?
28.47.
23.47. That is x. Then for that y, the same Pythagoras rule, y squared plus 7 squared is equals to 24 squared. Because that 24 is the longest side. Now 7 squared is 49. Y 24 squared is 576. Y squared is equals to 576 minus 49. Y squared is equals to what?
527.
527. Square root of that?
20.96.
527, that's 22.96 centimeter. Now, distance between the chord, not between the centers. Now, in the first example, we found the distance between the centers. But now, distance between the chords, because we have just one center here. Distance between the chords is now equals to s plus y, which is now, what is x? 23.47, and y is 22.96. And what is the total?
46.43.
46.43 centimeter. Now, there's no degree of accuracy in that question, so don't need to bother yourself. But if the two of them lie on the same side, say the same thing. This is 24. Then, this is another 24. This is another 24. This is another 24. Okay. So when you now bring out the triangle, the first one is 24, 7. We have this as 24, 7. While the second one is 24, 5. Now, we can call this one. Which one did I use at 24, 7 here? I used y here, right? Then, here we have 5 and I use x. Now, when you solve it, you still have the same answer here. But this time around, in order to find the distance between the chords, it's going to be what? Subtraction, not addition again. Are you with me now? You can see that if I want to find the distance between the chords now, it's going to be what? Subtraction. Is that taken? Okay, so that is that. Now, before you go to the next one too, I would like to give you class work on this. And the question is, let me write it on the board, class work. Two parallel chords lie on the same side of the center of a circle of radius 13 centimeter. The length of the chords are 10 centimeter and 24 centimeter. What is the distance between the chords? What is the distance between the chords? Now, that's the question. Let me give you 5 minutes to do this. Now, this time around, I need a boy to solve the question for us, because a girl solved the last one. So I want a boy to solve this. When you are done, signify. 169. 13 square is 169. 124. A square. Get your handwriting is visible. Okay, 25. 25, and the difference is 25 now. Okay? Okay? That's 144. So, okay, just want to use distance between the Z chords. Distance between the chords is equal to Please, is that the answer? Is that the answer? Yes. Please clap for him. Now, but it's something I want. There is no unit here. One. And from the diagram, the way you label it, you are now saying that B happens to be the height of this trapezium. I will advise you to label it here, A and B, because the way it is labeled now, you are saying that height of this trapezium is B. You are referring to the bigger one, triangle. Am I communicating? So what I'm saying is this. You don't need to write B here or A here. Just write A and B after bringing out the two triangles. Is that taken? Okay, so that's how to do about that one. Now, the last aspect of this length of chord, because we not finish it. Are you ready? You know, after giving you examples of this one too, I will still give you class work. Maybe I should go back to girls now. Then we now solve this question. Another girl may try to solve this one. An equilateral triangle of side 20 centimeter. An equilateral triangle of side 20 centimeter. An equilateral triangle of side 20 centimeter is inscribed in a circle. Is inscribed in a circle. Is inscribed in a circle. To stop. Calculate the distance of a side of the triangle. Calculate the distance of a side of the triangle from the center of the circle. Calculate the distance of a side of the triangle from the center of the circle. Now look at this one. We have an equilateral triangle that is inscribed inside a circle. Now let me first draw a circle. This is a circle. This is a circle. This is a circle. Now we now have equilateral triangle inside this. This is the first chord. We have a chord here. We have another one. We have the third side here. This, what is called inscribed. You know that in construction, you want to do this. Who can tell me the procedure of getting this circumscribed circle? In construction, you want to circumscribe. I need two angles. Okay, if you know that if you bisect any two angles, that is what is called inscribe.
Bisect any two sides.
Any two sides. You bisect any two sides. When you have a triangle like this, when you bisect any two sides, something like this, and you also bisect this one, the point of intersection is the center. Then you now use 2. Is that? But if you bisect any two angles, that is inscribed. Okay. Now we also have ascribe. Aha. So what I'm saying here is that this is how to circumscribe a triangle. Then the length is 20 centimeter. 20 centimeter and 20 centimeter. Now that we have equilateral, you can divide it in such a way that you are going to have two congruent triangles. Now what I'm saying is this. If you draw a line from this, you know this is 10. This is 10. Then you can still extend this line in such a way that it will now give us two congruent triangles. But if you have an isosceles triangle, because I'm going to give you a question on that isosceles, where two sides are equal. When you draw this, let's assume that we have isosceles, where the thing is 20, 20, let's say 15. It is only this way that you can divide this. Because, okay, let me change this to 20, 15, 20. And you now divide it like this, it's wrong. Because if you divide it like this and you now get 20, 10, 10. This one is now 10, 15. The two triangles are not congruent and it is wrong. If you now have it in this form now, 20, 20, I will divide it like this. So that you give me 27.5, 27.5. Is that taken? Yes. Now with this is 10, 10. I can draw a radius. This is a radius. This is R. Now don't forget that this line too is called what? Radius. Abi? Now, because whatever you have here is equals to this. You know, when we get to that other theorems, angle as center twice, angle as whatever. Whatever you have here is equals to this. That is what is called base angles of isosceles triangle. They are equal. Now, as this one is R and this one is R2, I can get the length, the full length of this. Maybe let me label it as A, B, C, and call this one D. So I can get BD. I mean the full length of that BD. You know, when you bring out the triangle, when you bring out this triangle, you bring out this triangle as this is A, B, D. So this one is 20, this is 10. I will use Pythagoras rule to get that BD. BD square plus 10 square is equals to 20 square. Then we have BD square plus 100 equals to 400, that is 20 square. BD square is equals to 400 minus 100. BD square is equals to 300. BD is now equals to square root of 300, and that is what? 17.32 centimeter. That is BD. But what we are looking for is not even BD. We are trying to find a side. I mean, a side of the triangle from the center, I mean, which is this. This is the distance we are looking for. But there's no way I can get this distance without first getting what? R. Now, what I will now do is this. If BD is 13.32, you know, BD is this, everything that we have here. And if this one is R, this is 13.32 minus R. You know that if the full length of something is 20, if this one is 20, and this one is known as 15, what is the remaining one? 20 minus 15. So if this one is known as R, and the full length is 17.32, for me to get this, it's going to be minus R. You know, my answer will be in terms of R. Then I will still go back to that Pythagoras rule. Because now, using this triangle, Using this triangle now, we have 17.32 minus r, 10. Why this one is what? R. It is still Pythagoras rule. And which one is the longest side then? R is the longest side. So it is that R that will stand on its own. So we now have this as r squared is equals to 17.32 minus r squared plus 10 squared. And now this is where students always make mistake. This one is not 17.32 square minus r squared. It's wrong. You cannot distribute that square over 17.32 and r, because when you have something like this, x minus y squared, it is wrong for one to say x squared minus, it's wrong for one to say x squared minus y squared. This is the difference of two squares now. Our identity of this one is product of sum and difference. But if it is this one, is that you want to repeat whatever you have inside the bracket twice. S minus y, s minus y. So, but if it is xy, we end that, xy is times, and I can say s squared, y squared. That one is multiplication. Likewise for divisions too. But if it is subtraction or addition, you cannot distribute it. So, the best way to expand this is to take it as r squared is equals to 17.32 minus r, 17.32 minus r plus 100. This is how to expand it. I will repeat the bracket. It is not difference of 2 squared. Then we have r squared equals to 17.32 times 17.32 is what? 299.98 minus 17.32r minus 17.32r plus r squared. Minus times minus. Okay? Then plus 100. I want it is clear. The way I expanded the bracket. Okay. So r squared 299 plus 100. That's 399.98 minus
34.6.
minus 34.64. Abi?
Yes, sir.
Okay. Plus r squared. So r squared will come here. R squared minus r squared. Why this one too is 399.98 minus 34.64r. This one is already 0. Abi? 399.98 minus 34.64r. Take this one to this side. Minus will change to what? Plus. 64r equals to 399.98. R is now equals to 399.98 all over 34.64. What's the answer? What is it? 11.55 centimeter. If the radius is 11.55 centimeter, then we can now find the length of one side, or the length of a side of the triangle from the center. Length of a side, length of a side of the triangle from the center of the circle is 17.32 minus r. If that question requires only radius, I will stop here. But now I will continue. 17.32 minus, what is the radius? 11.55. And what is the answer? 5.77 centimeters. Always put your unit on. Is that taken? Write it down. And now let me give you what to do as class work, because I still want to explain another theorem, which is, this is just one theorem. The line that is drawn from the center is perpendicular to the chord. That is the theorem. Now I still want to explain angle as center twice, angle as circumference today. An isosceles triangle, an isosceles triangle ABC An isosceles triangle ABC has its vertices on a circle if AB equals 13 centimeter, BC 13 centimeter, and AC 10 centimeter. Calculate A, the height BM of the triangle. B, the radius of the circle. So the nearest whole centimeter. Now this is the question, but you cannot see that I have changed the question to isosceles triangle. I've just explained that when you have isosceles, you must be mindful of the way you want to bisect it, or you want to divide the diagram, so that we now have two congruent triangles. You know, my own is equilateral. I can divide it like this. I can divide it like this. I can divide it like this. I will still be having the same thing. But now that we have isosceles, you must be mindful of the way you are going to divide it to. Otherwise, you will not get the correct answer. Is that taken? Now, let me first give you 5 minutes to do this. Then I need a girl, this time around, another girl to come and solve the question for us. S is 12, okay? Okay. can use the other side. I just see this. Yeah. Oh yeah, help out to divide this. 169 all over 24 is what?
7.04.
7.04 centimeter. Do you have degree of accuracy?
Yes, sir.
Oh yeah, approximate. Is this the answer?
Yes.
Please clap for her. So that is how to solve the question. I hope it is clear now. Abi? Okay. In the diagram below, comma, capital letter P, comma Q and R, capital letter P, comma Q and R are points on a circle. Are points on a circle. Are points on a circle. Can I clear this? Hello?
Yes, sir.
Okay, have you written it? Our point on the circle full stop. If OPQ is equals to 30, if OPQ equals to 38 degrees, what is the size? What is the size of PRQ? PRQ. What is the size of PRQ? This is the diagram. This is 38. Now, number 2. Number 2, in the diagram below, calculate PSR. Let me just draw the diagram here. Calculate PSR. So this is LCM. Is that taken? This is LCM. PS, calculate PSR.